drift towards one side, and intention is fine. Now what is actually persuading them to keep drifting towards one side? 2 points. And is there any source, or is there any strong reason as to why they are trying to drift? So I'll have to learn about these 3 points. So before that, I'll try to for me to explain that, I'll use a conductor. Now this conductor, obviously, conductor meaning the running electrons will be able to move from point A to point B. So instead of using point A and point B, I'll try to connect both of them to one specific battery. Now, what does the battery do? This explanation in yesterday's class I've given to you. Okay, 1 second. Let me draw a battery. Please don't get confused. I am not drawing cell. I am drawing batteries. Now, what's the meaning of a battery and what's the difference between a cell and a battery? The meaning of a battery is nothing but combination of cells arranged in a specific order. Okay. Now, what do I mean by specific order? So let's say if I use this one big line and one small line, one of them, one combination will be called a cell. But if I use multiple combos like this, three or more put together will be called as a battery. Okay. So right now I'll talk about a battery. Fine. But important here also, you're supposed to talk about one big line, one small line, one big line, one small line. Now, which obviously means the bigger line will be representing the positive side of the battery. The smaller line will be able to represent the negative side of the battery. Now, what is the meaning of positive and what is the meaning of negative in this specific case? Important. Meaning of positive meaning, the plus sign here in the sense, it is a higher potential. Okay, it is a higher potential. Remember, positive will always be at the higher end. Automatically, this minus will represent the lower potential or the negative potential. Fine. Now what's going to happen? Since it's a conductor here, 1 second. Since it's a conductor, electrons will have to flow from one end to the other end. Okay. Now, understand, wantedly, I'll do something. So wantedly, I'll start producing electric field. Now, how do we produce electric field? Obviously, with the help of charges. Now, I am telling, let's start producing electric field in this direction. Okay. So from 1 minute, I'll start producing electric field from my left towards my right. So left to right, I'm producing electric field. Please remember this. Now, why am I doing this? Again, I want to test, guys, don't get confused, the meaning of lowercase e meaning electrons. Okay, the meaning of capital E is electric field. Fine, both of them are not the same. Stop getting confused in that aspect there. Okay, I've seen a lot of people trying to, they get the concepts wrong. Basically, you should common sense, like understand what is electric field and what is electrons. Now, electric field, what am I doing? Wantedly pass it from my left towards my right. Okay. Electrons is there inside the conductor. Keep this also in mind. Now, what we see here is these electrons will start behaving slightly differently. Slightly different to what? Slightly differently to electric field. It will stop obeying electric field. Okay, that's the intention. It will stop obeying. No obeying electric field. Fine. Which means if the electric field is from your left to right, the electrons will start moving in the opposite direction. Okay, this is in the opposite direction. Now, why is this happening? That is because if you observe carefully, electron is not obeying E. No, done. Okay, not obeying E, done. But it is actually obeying. Don't you think the potential here? Fine. It is in simple language. It is trying to go towards a place with a higher potential. Minus was a lower potential. Plus was a higher potential. Electrons was there. It is only trying to go towards a higher potential. How do you represent potential? Yesterday's concept. Okay, V. Fine. Now it is going towards this higher potential with some kind of velocity, but obviously there is some kind of opposition with the electric field. It is wanting to go towards the left, but there's some kind of opposition from it in the right. So therefore, even though it is trying to go smoothly, this electric field will not let. Okay. Therefore, it starts drifting. That drifting will happen with some velocity called as drift velocity. This is the whole concept. In a sense, 30% of the concept is what I covered till now. Fine. To recap in one statement, electron has to travel from one point to another point. Now, which point? It will always travel in the opposite direction of the electric field. Why? It should not obey. Fine. That is rule number 1. Rule number 2 is, if it is not obeying A, it simply means it is obeying somebody else. You guys always understand here, if you are not obeying a person, in the other language, you are trying to obey somebody else's principles. You're obeying somebody end of the day, but it is just that you're not obeying the people whom you know or the people whom you trust. That's the whole point. So the electric field, the electron here will stop obeying electric field and start trying to obey the potential here. Potential meaning it will start going towards the higher potential, which is the plus here. So nothing but opposite of field, it starts going. But the moment it starts going, it'll obviously feel some kind of obstruction from the electric field. And even though this is happening, the electron will not pass smoothly, but will start drifting towards the left hand side. The drifting is happening with some kind of pace. That pace or the velocity with which it drifts against the electric field and towards the higher potential. I'll repeat that. The velocity with which it drifts, it meaning electrons, against the electric field and towards the higher potential. This concept put together will be called as drift velocity. That's the meaning of it. Okay, that's the meaning of it. Now there's a problem. It is drifting. Okay. Now obviously, do you think electric field will help it? Obviously, no. Why? It's disobeying. No. So electric field will leave it. Done. Now, what are the problem which it will face? These electrons, obviously, I've only drawn one. There'll be millions here. These millions of electrons, when they're trying to go from left to right, they'll see a lot of metal ions. Okay, metal ions here, whatever M is there, all those things are metal ions. Okay, this electron will hit a metal ion like this. Fine, it'll go hit. The moment, guys, imagine metal ions are like walls. Fine, electrons are highly charged, highly energetic there. So just imagine somebody who's highly energetic. Just imagine a crazy car moving with top speed. I'm talking about crazy car and top speed. So it's a deadly combination. So crazy car moving with a top speed, if it goes and hits an obstacle, two things will happen. Okay. One of the thing. First of all, it'll change direction. Okay, because whatever happens, however, guys, end of the day, it's a car, it's not a bloody tank. Okay, so it has to crash. So let's say the metal is like a wall. It goes, hits the metal ion. Because the metal ion is very strong compared to electrons, the electrons will lose some of its energy. And second thing what will happen is, it will change the direction. It changes like this. Fine. But unfortunately, from this metal ion to this metal ion, there's only some gap, which means everybody knows that once it hits the metal ion, it got the direction changed. Okay, the direction changed, and it is coming towards the other metal ion. But you gotta keep one thing in mind. This is metal ion 1, and this is metal ion 2. 1 and 2. Can you see 2 being in front of 1? And that front of 1 in other language means it is going towards the positive side. It is not going back towards 5. Metal ion 5, just imagine that number to be 5. It is going from 1 to 2 and not from 1 to 5. Why won't it go from 1 to 5? Because primary job is to go towards a higher potential and not a lower potential. Okay. So since 5 is at a lower potential, it might have come from 5 to 1, acceptable. It can come from 5 to 1, acceptable. It cannot go from 1 to 5. Remember this. So right now it hit 1, direction changed, it lost some of its energy, it still moved towards the second metal ion. Guys, understand, doesn't mean it has zero energy. It has energy, little less it became. Hit the second metal ion, what will it do? Again change direction and keep moving like this. Fine. So this hits, changes direction, loses some energy, goes. Hits, changes direction, moves some energy, and so if you see the actual spot, it will be like this. Very haphazard it will be. But if you see, it is always moving towards one direction. Okay, this all is correct only. It is not wrong. It is not because by mistake I made. Wantedly it will happen. It let somebody, it'll come back, it'll go, it'll come back. Okay, this is wrong. This part is wrong. It cannot come back. No, 1 second, wait. So it'll be more like a path which is like this. Okay, so hits a metal ion, goes fronts, hits, loses energy, moves, hits, moves, hits, moves, hits, moves, keeps happening. But if you see, it is always traveling towards my left, which means going towards the higher potential, and it is traveling, meaning it is drifting, because opposite to that E was there, no? So it is drifting there. So this concept where it keeps drifting towards the higher potential against electric field is called as drift velocity. And between each collision, okay, it'll have some time. This time it is called as relaxation time. Fine. It is you cannot use the word resting time there, because it is actually not resting. It is only trying to change its path, and during the path it might find one more electron. Now if you ask me, sir, by chance if it finds one more here, what will happen? Again, from here to here, it's called as tau, relaxation time. No, nothing happened. It hits the metal ion, moves again, comes here, hits somebody else. So it can keep on happening, because it completely depends on the distribution of the metal ions, which I or you cannot control. The metal ion, it can be wherever possible, whenever possible. Okay, so it completely depends on that tau and the metal ion. Me or you cannot control, and the only thing that we can control here is the potential. So I will be able to decide, okay, which side is the higher potential and which side is the lower potential, because I'm the one who's trying to arrange the battery here. So if the batteries If the battery's bigger line comes towards my right, that will become my positive potential. If it comes towards my left, this is the only thing that I can take place of. And after this, I can also slightly influence the electric field. But once I set one and two. Once I set the potential, once I set the field, whatever is happening inside, nothing will be able to control. Okay, all these things will be dominated by the electron and more dominated by the metal ion. So you can't even convince the metal ion to move. You can't even tell the electron to follow. I mean to move to go in a specific manner. All these things put together will be called as drift velocity. Okay. Now should you write any notes for this? Today's class, don't write anything. I'll just send you the notes later once I'm done with this. Fine. So is there any pace or is there any value for drift velocity? Yeah, there is. This is based on a lot of research and all these things because it's obviously difficult. So it is said that it drifts in a velocity of 10 to the power minus 4 meter per second. Okay. Now, obviously, don't ask me, sir, why is it so slow? Guys, come on. It is hitting millions of metal ions, and we are trying to obstruct it with electric field. It is going against. You should appreciate that for that. Okay. And if you are complaining, telling it is moving slow, it is moving fast, doesn't matter. It's going to drift, but okay. Remember this. Now, will they ask you any kind of expression for drift velocity? They will ask you. So don't write anything right now. I'll try to explain and then give you some time. Expression for drift velocity. Vd meaning drift velocity. V in this case is not potential. Don't get confused. And one mistake I've made here. This V, avoid writing in caps. Okay. Risky. Avoid writing in caps. Try to use what happened? Lowercase vd. Okay, drift velocity. Now let's try to understand. Let's go back to somewhere in your 10th standard. Okay, I'll combine 10th and 12th right now. 9th and 12th, in fact. So you guys might have come across something called as Newton's second law of motion, which says F equals ma. I'll write that. F equals m dot a. Now, why am I doing this? Because end of the day, what are we talking about? We're talking about electron. Electron also has some mass and it is moving. Wherever a moment is there, 100% there will be something called as acceleration or velocity. So all these things I'm trying to talk about right now. Fine. So I'll write acceleration. Since F equals m by m into a will be equal to F by m. F by m. Obviously, force is a vector quantity. Now, the other day we learnt in first chapter of statics, we learnt F equals Q into E, where Q is the charge and E is the electric field. Now, why is it important for me to get electric field into picture? Because end of the day, I am the one who's trying to give that electric field concept here. Look at this. I told no, we'll be starting with electric field there. So electric field concept, I'm the one who's introducing there. So I'll have to bring E into picture somehow, and I choose to use this. Now understand here, F means force, understood. E means electric field, done. What is the meaning of Q? Q means charge. In this case or in this question, what charge are we talking about? Negative charge. Why are we talking about negative charge? Because end of the day, it's an electron. So I'll write negative. What charge? Electron dot E as it is, whole thing divided by m. So this will be my first step. Newton's second law of motion, I change the value of F and get this into concept here. Fine. Now, again, somewhere in 9th standard, we also learned one of the equations of motion, velocity equation. The most easiest equation amongst the three was V equals U plus AT. So I'll take some time. I'll try to figure out what and all are the vector quantities. So V is a vector, U is a vector. Automatically, A is also a vector quantity. All these things I realize it's a vector quantity. Fine. We'll keep this into picture. Fine. Now understand here. It will always start from rest, because at end of the day, if I do not connect this, do you think it will take? Obviously, no. If something is starting from rest, other day only we realize that initial velocity will be equal to 0. U became 0. So in V equals U plus AT, U became 0. Whatever is remaining is V and AT. Now, this is one step I'll write, drift velocity. Whatever remains, velocity, will obviously start drifting towards the potential. So it becomes Vd with the thing. A's answer I just now found, minus E dot E by M into time. Guys, just now I told you, the time in between two collisions, this will be called as tau. What does that tau mean? Relaxation time. The relaxation time is nothing but the time interval between two collisions. Fine. It's called as relaxation time. I won't write T. Instead of that, I'll write tau. This is my formula for, drift velocity. Okay, this is my formula for drift velocity. Now, what is the negative sign Indicate indicates two things. One is that electron is negative, but most importantly, it tells that electron is always in the opposite direction of electric field. That's the meaning of it. Okay. So here, negative sign tells electron is opposite to electric field. That's the meaning of it. Remember it. Okay. Important. Derivation not important, but using this, I'll frame one more formula. That formula is important for your numericals. Okay. This derivation usually won't come. Correct. So understand, guys. In this case, negative has how many meanings? Two meanings. The first thing is E is electron is negative. Done. Second meaning is electron is always opposite to that of electric field. And what is the meaning of tau? Tau we are meaning relaxation time. Relaxation time. Okay. M is what? Mass of electron. Okay. VD is what? Drift velocity. So copy this now. So write expression for with drift velocity. Start copying this. 3 steps, more than enough. Fast, I'll give you 2 minutes. Done. Fast, 2 minutes. No. My thing is on, Lida. Not here. Done. Next. There's a concept called as mobility, not required, but I'll introduce something called as, you know, basically here also when the electrons are flowing, end of the day, yesterday's class we learned rate of flow of charge or rate of flow of electrons will give us what? Current. That we know this. Fine. Now, we spoke about drift velocity, which means right now electrons are drifting from one place to another place. Drifting meaning still some kind of moment is there, which 100% will produce current. Now, how much current will it produce and how will it produce? We'll have to find out. So what we'll do, a similar, diagram I'll draw. What is this? It's again a conductor. Now understand, it's a basically best reference for this is a pipe basically. Okay, let's talk about a PVC pipe. Both the ends are closed. Fine, both the ends are closed. Now just imagine in a PVC pipe, guys. Just imagine a cylinder. Okay, a cylinder like this, which has something filled in it like this. Okay, so it is not a hollow cylinder. It is a completely filled cylinder, solid cylinder. It is. Okay, now which means by chance if I cut there inside, I won't find hollow things. I'll find something to be filled. Let's say if you fill it with cement, all those things, you find cement only like this. Okay, so that's the meaning of dotted lines. Now, why have I drawn those two dotted circles? Is because even though the complete thing might be there, my focus is only between these two dotted circles. Now, only to confuse you, I will change the direction because just now I told you, no, the only thing which is there in my control is keeping the direction in mind. So, wantedly, I'll change the directions. So how do you first of all find it? You'll have to figure out where the bigger line is. The bigger line here is towards your right side, which means plus is here, minus is here. Electrons will go towards the plus, which means electrons will start drifting like this. Okay. Now, if it is drifting from your left to right, automatically electric field, whatever being produced, will be in the opposite directions, will be like this. Okay, that's the meaning. Now, understand one concept. It is drifting from left to right. Electric field is from right to left. It will produce some current. Obviously, which direction will the current be in? Very important question. Current will always be in the direction of electric field. Okay, remember this. Now, it's kind of difficult for you guys to understand, I realize, but E and I are together in this case. Fine. So electrons in this other direction, I in the opposite direction. Fine. Now, how do we start off? I'm supposed to find the value of I right now. So how do we start off? We start off by finding the volume of this part, the highlighted part. I'll use a different color. Wait. With this part, I'll use. Okay. Only that black part is my intention right now. Nothing else I'm focusing on. Now that obviously will have a volume because end of the day it's a 3D figure. Any 3D figure will have volume. Volume, don't you think, is given by area into some kind of length? Fine. I'll write L. But the problem here is L meaning the complete length of the conductor. Am I talking about the complete length? No. I'm talking only about a part of it. So since I'm talking only about a part of it, I'll write delta L or delta X. Anything is fine. Delta L or delta X. So what's the meaning of delta L? All those things which are in black right now is nothing but delta L. What's the meaning of L? Full thing is the length of the conductor. Delta L is a small part of it. That's the meaning. Okay. So first you find volume. Okay. Now understand, this is number one. Number of free electrons. Now, this is a proper hypothetical situation because obviously I won't be able to draw millions of electrons right now. I will be able to draw only one. No, like, obviously, do you think only one is there? No. So I am asking you in this black path. Okay. Do you think only one will flow? Obviously, no. There will be millions flowing. But I can't take millions. Since I can't take a specific number, I'll take the value of n. So I am telling n number of electrons are flowing in what? In that volume. So can I write a number of free electrons nothing but n into V? But the crazy thing is I know the value of volume. What is the value of volume? A into delta L. So I am telling the total number of free electrons passing in that black part. Okay. The total number of free electrons passing in that black part is n into A dot or anything dot delta L. This is the total number of free electrons passing. Now, the value of n can be 1, the value of n can be 100, the value of n can be million, the value of n can be 10 million. So, according to me, it will be like millions of it. But let's talk about easier numbers right now. So, first thing I find the volume of the element, the highlighted part. Next, I'll figure out, okay, how many electrons are passing through it. I figured it out. The answer is n A dot delta L. Done. Now, where n is the what? N is the number of free electrons per unit. Okay, so I'll write the meaning of n here. N is nothing but number of free electrons. Now, why am I doing this? Because, okay, I'll give an explanation. Just imagine your college is there. Okay, this happens very often in Christ College. They make people stand in queues like this. Okay, so if approximately the principal asks them what's the attendance for today's assembly, they won't sit and do 1, 2, 3, 4, 5, 6 for all of them. First of all, they'll count one. Okay, they'll be like, this row has 50 people. And they'll count the number of rows. Okay, they'll count the number of rows. 50 into, let's say 10. They'll be like, approximately 500 people is what they'll tell. They will not tell 498, 497 because it's damn difficult. Within 1 second, if you want me to tell, I'll count the one thing and on an approximate scale, I'll tell. So approximately in this specific line, how many students were there? 50 students were there. That 50 is nothing but the value of n. Okay, number of students per line, number of electrons per unit or per length. Okay, per unit length, per unit volume. All those things will be called as This is actually per unit volume only. A line I told. No, what is this line? Line is you're trying to cover some space also. So 50 is nothing but not the total students. 50 is the number of students per unit volume. Okay. So how many unit volumes are there? 10 unit volumes are there. So 50 into 10 gives us the total answer. That's the meaning of it. So the value of n here is number of free electrons per unit volume. Unit volume. Okay, just like that distribution, there'll be lines here also 1, 2, 3, 4, 4. In one line, there are, let's say, 10,000 electrons. Then they'll count the number of lines. And then they'll tell, okay, totally it is 10,000. Totally it is 1 lakh and things like that they'll tell. Okay, now done. We found the value of n, we found the value of v. All till now, everything is fine. So, neither n means total charge, n means total number of electrons. That's why using that, I'll be able to find total charge. Don't get confused. Now, guys, I'm telling you, there are 10 electrons. 10 electrons is a number. What's the total charge? Obviously, you will do 10 into 1.6 into 10 to the power minus 19. Why do you do this? Because each electron has one specific charge, correct? And this charge is nothing but Q. And all these things we learned in yesterday's class only. Fine. Or we write it as E, no? 1 second. We write it as E. So if 10 electrons is the total number of electrons. What's the total charge carried? 10E. 10 is the total number of electrons. E is the charge carried by each electron. Now, I am telling there are so many electrons passing. Fine. What's the total charge? So, you will write total charge equals, first of all, copy the number of electrons. What is it? N A dot delta L. All of this is my electron. Put each of the electrons carry some charge, and that charge is nothing but E. So Na delta L into E is the total charge. What's the reference for this? This is the reference. Each electron carries a charge. Yesterday's class, first question we solved C. E's value also we used. That's the meaning of it. So 3 things you found along with one diagram. Telling, okay, we found the volume of an element. Sorry, not the complete volume, a part of volume. And then we realized, then we calculate how many electrons are there totally done. And total electrons meaning I will be able to find the total charge. All these things I find. Only now. Okay, only now I'll try to find the answer for drift velocity. Okay, drift velocity, how do you find? Now understand, remember one thing, okay. Let's go back to 9th standard again. Velocity or speed, both of them are same. Velocity is nothing but displacement by time. Displacement by time. I'm using this concept right now, okay. Drift velocity will be given by displacement by time again. By t I'll write. The problem is, what is the displacement? You guys understand, displacement is also some kind of what covered? Length covered. Okay, some kind of what covered? Length covered. So in the whole assumption concept here, what was my length? Delta L. So therefore VD will be given by delta L. Since I use the symbol delta on top, delta L will get covered in delta T time, not T time, delta T time. Remember this. So I use 9th standard concept here, telling velocity equals displacement by time taken. In displacement meaning some sort of length. I come back to my data. I will see what length I've used. I used delta L. I'll write delta L. So delta L gets covered in delta T time. Done. So I came up with an expression of VD. I did not copy anything from here. Okay. If it is required, not required, we'll do little later. We'll do. But till now, I've not copied anything. I've not taken any references. All these things are completely fresh. All these things belong only to this specific diagram. Nothing previously we've learned. Okay. I mean, obviously, we're talking about 9th standard here and there. Now we have so much. We obviously found total charge. We also brought time into picture. After bringing charge and time into picture, if we do not talk about current, it won't make any sense. So yesterday's concept, current is given by rate of flow of charge. What is charge? Delta Q in this case. Why all deltas will use? Because, guys, common sense, in delta part of the cylinder, only delta Q is expected. No. So therefore, I write delta Q divided by delta time. Okay. Delta meaning a small part of Q, a small part of T. Sorry. Okay, done with this. Now, what's the value of delta Q? Guys, 1 second, I forgot to write something. Total charge is nothing but delta Q. That's how we represent charge, no? So charge equals Q by T, done. Denominator does not change. So first I'll write at the denominator. Do I know the answer for delta Q? Yes. Na delta L into E. I will copy this here. From there to here I copy. N dot A dot delta L dot E. What's the meaning of Q? Charge. We had found the value of charge already. Now, I will have to set few things right here. Why? Because if you observe both the deltas, I'll only put brackets for deltas here. Delta L and delta T, I'll put brackets. Whatever is remaining, I'll write outside. Fine. So, left-hand side, I remained. I copied. N remained. A remained. Delta L by delta T, just now we came across one reaction here. What is it? VD, but before that, one E also is there. I'll write the E then. Delta L by delta T is nothing but VD. So current equals NEAVD. Okay, NEAVD or NAEVD, anything. I am more comfortable with NEAVD. Okay, so current which is passing or drifting through the conductor at that point of time is given by the formula NEAVD, where N is the number of free electrons per unit volume. Again, we have to complete that. A is the area of the metal conductor. E is the charge on each electron, and Vd is the drift velocity. Fine. So we found all these things. We found the value of I. We'll go one step ahead. We won't stop here. Reason is because yesterday's class, we also learned a concept called as current density. Current density was represented by the letter J. J was equal to I by A. Now, do I know the answer for I? Yeah. So I'll copy it. NEAVD divided by A. A and A gets cancelled. What remains? J remains. NEVD is the answer. J equals NEVD is the answer. So remember this. Fine. So we found we found I. Immediately, we also found the value of A. Fine. Now, we won't stop here. J equals NEVD is there. I'll go. I'll rewrite that again because continuation is required. J equals NEVD. Now I'll take the reference. I'll keep the N and E as it is. We found the answer for VD in a different concept here. Minus E dot E by M by into T. I'll copy that. Minus E electrons, electric field by M dot relaxation time, tau equals J. Now if you see here, J equals, again guys, I can ignore the minus because what does the minus indicate? That E and E are in opposite direction. I'll ignore the minus, no problem. So N remains E square capital E by T by M. Okay, this is the meaning. Few people write it like this also. They'll write the tau outside to make it look little aesthetic. Okay, I have no idea why they keep doing all these things. Fine, but they do it. Fine. Now, we found the value of J. Yesterday's class, once we found the value of J, we also spoke something about conductivity. Conductivity and Ohm's law and all we used, and we came up with the concept. J equals sigma into E, where sigma is nothing but conductivity. Yesterday's class. Fine. So now what I'll do, okay, look at this. Both the left hand sides are same. So what can I do? I will be able to equate the right hand sides. Here the right hand side is N dot E square dot E by M dot tau equals sigma into E. What gets cancelled? E and E gets cancelled. Right hand side, what remains? Sigma remains, meaning conductivity. Here, Ne square tau by M. So this derivation is very important because we keep solving and we keep getting answers. Now, what will this be called as? Electrical conductivity. Conductivity. So that will be a derivation usually. They'll be like derive sigma equals Ne square tau by M. Okay, you should do all these things. Now, don't get scared. It's only like 2 slides. You'll have to focus more on the first place here. Now, listen. I'll repeat this like in one moment. I'll finish off. See, understand until you find J. Until you find J and you get an answer. So basically full of your first slide, absolutely 0 references. I'm only talking about 9 standards maximum. But the moment I go to the next slide, for this VD, I take a reference from my previous derivation here. Until then, no reference. Okay. And again, once I get VD, for the next, for the connectivity also, I will take a reference from yesterday's class. So the first slide completely based on the diagram. Second slide completely based on references. Remember this. So understand full conductor, too difficult for us to calculate. We'll talk about only one part of it. We realize electron is going in towards left to right, towards higher potential. Opposite direction is E. Whatever direction E is in, I is also in the same direction. So I'm supposed to calculate something called as volume. Volume is given by A into L. But since we're talking about a small part, delta L. Done. Number of free electrons is given by N into A into delta L. You copy the V and just write N next to it. What's the meaning of N? Number of free electrons per unit volume. Done with this. Now, based on the number of free electrons, you will be able to carry total charge. I explain it to you. Copy the same expression. Put the letter E there. E meaning charge on each electron. Then VD. is again ninth standard explanation. Well, displacement by time. Displacement is nothing but some kind of length covered. In this concept, length covered is delta L by delta T. I am done. Now we found all these things. I can easily find the value of I given by the formula rate of flow of charge. So delta Q by delta T. You copy the delta Q's value here, delta T's value. You realize delta L and delta T together is giving me some reference called as VD. So you come across the answer for I first. I equals NEAVD. Fine. The moment you find I, you also find J. Yesterday's concept, current density. J equals I by A. You copy the same NEAVD and you get the answer for J. Do not mark the answer for J here because I would remember this. If you get the I right, everything else follows. Okay, I equals NEAVD. You also got J right. You copy the J again, but now instead of VD, you apply the previous concept, whatever I told you, EE by M into tau. You apply that, you multiply E times E gives you E square, and you got some answer. But we did not stop at one thing with J. We spoke about two things yesterday. So J was also equal to sigma. Yesterday's class we spoke about that no relationship between J and D. That derivation I'm talking about here. This was my answer. Okay. So J equals sigma into A, where sigma means conductivity. To the full form is electrical conductivity. Both the left hand sides are equal. So we start equating the right hand side. You copy the right hand side from here. You copy from here. You see if something gets cancelled. E and E gets cancelled. Whatever remained, you will write, and that's the answer for sigma, also called as electrical conductivity. It is coming. 5 marks. Okay, copy this. Please go step by step. Start with the drawing. Left hand side, fill all the data and start writing stuff. Do. 5 minutes. Start with the diagram. Done. I'll go to the next slide. This has to be below that VD part, okay? And the J part has to be below the fast. The J part has to be below the I part. It has to be one below the other. Remember that. And I would bracket this because that's what gives me the answer for VD. I'll go to the next slide. Yeah, copy. Done. Mark, this to be 5 marks. It's coming. We spoke about limitations of Ohm's law. All those things are done. Combination of resistors. I think we'll solve a circuit. Cells will do in tomorrow's class, guys. I'm finding a circuit we can solve right now. I'm talking about a resistor. Wheatstone bridge is also there. Okay, it's fine. Yeah. We'll solve a circuit diagram. So start doing it. We'll solve two, in fact. Start drawing along with me itself. Resistors, not there in syllabus, but obviously we'll be using the formula. Derivation is not there. That's what I meant. Okay. The formula has to be used. And point A, point B. Both of them are wires. They're asking me to find resistance between A and B. Okay. All the resistors are named or numbered 10 ohm, 10 ohm, 10 ohm, and 10 ohm. I don't know if you guys have remembered this in 10th standard. I'll do this. Okay, stop for a second. I'm supposed to go from A to B. Okay, so space your A. I mean, find your A, find your B. Done. It's on your left. From left to right, if I go in this path, I find two resistors. If I go in this path, I'm gonna find two resistors. Fine. Okay. So I'll talk about the path first. First, I find the 10, which is directly in contact with the other 10, which means this 10 and this 10, the one which I ticked right now, both of them are in series with each other. If two resistors are in series with each other, we obviously add them. So the value becomes 20. Fine. So this is A, this is B. I chose path 1. From path 1, I found two of them are in series. Series meaning should have a common point. Okay, and obviously you know the meaning of series. Fine. So 20. And in path number 2, if you see this 10 and this 10, they're in the same flow, which means again there are 20. So the simplified version of the circuit looks like this. But I still haven't found my answer. Fine. What is the answer right now? That between A and B, there are two resistors, but this time both of them are parallel to each other. Fine, because between this resistor and the below resistor, there are separate points, there are separate junctions. Wherever there are separate junctions, both of them will be what? A parallel. Fine. So parallel, what do you do? R 1 by RP will be equal to 1 by 20 plus 1 by 20. There's a shortcut also for this. I realize that, but I'm doing the complete part. So here, you obviously, LCM is 20 here. So 21 plus 1 gives you 2. So 1 by RP equals 2 by 20, which means RP, flip it, becomes 20 by 2. The answer is 10 ohm. You obviously can use a shortcut. I didn't use it. So what's the shortcut? You can directly write RP equals 20 into 20 by 20. That also you can do. Okay, the shortcut goes like this. You multiply both the resistors if they're in parallel. 20 into 20 divided by 20 plus 20. 20 plus 20, the answer is 40. So 20 times 1, 20 times 2, 2 times 1, 2 times 10, RP equals 10 ohm. That's the meaning of this. Okay, will this be asked? Sometimes, yeah. I've never seen a typical numerical being asked from this yet, but yeah, they might also ask. So we'll just brush it up, that's all. One circuit diagram will come in your competitive exam, so that's why it's important. Copy this. So the final answer for this is 10. 10 ohm. It was a very simple one. Done. The other circuit. Just draw the circuit. Even if you don't copy the answer, it's fine. If you guys understand, more than enough. Next. This is an important. It's a nice circuit. The next one. 1, 2, 3. Okay. A and B are at the extremes. A is here, B is here. So now what do I do? From A to here, there's a wire. From here to here, there's a wire. This concept is called as shorting. Okay. Always understand one concept when it comes to shorting. From whichever point, look at the points where it has been shorted. All those points will be parallel in nature. Okay, I'll repeat that. All the points which are shorted will be parallel in nature. So basically, this 10 and this 10 are parallel in nature. Okay, so 1, here, 2. So this was 10, this was 10. This was as it is. So now A was here, B was here. This is a simplified circuit. Why was it? Does it look like this? It got shorted. Now this 10 and 10, I'll be able to apply the trick. 10 into 10 by 10 plus 10, the answer is 20. Gets cancelled. 10 by 2, 5. 5 is the answer. So 5 is the answer for the first part. Okay. So it becomes like this. 5, put a dot there, 10. So 5 and 10. 5 plus 10, both of them are in series. So the answer between A and B, or RAB, will be equal to 15 ohm. That's your part. Correct? So understand shorting meaning parallel. This part is shorting. How do you know if something is shorted? Wires. So these lines here are called as wires. Practical application of this, I'll tell you. When you, okay, for example, if you guys stay in a place where nearby there's a ground, okay, playground, all these playgrounds will have floodlights. None of them will have switches. Fine. You guys might have wondered, no, who's going to come and switch it on? There's nobody going to switch it on. So one of the circuits will be there. There'll be a fuse. Fine. And there'll be multiple fuses. Now, how is it? All, okay, let's say there are around 5 to 8 floodlights. 8, let's say. 8 floodlights will have a bunch of 3 fuses. They'll take 2 wires. They'll short there'll be a fuse 1 here. There'll be fuse 2. There'll be fuse 3. Okay. They'll take 2 wires. It'll literally be so much. That's the length of the wire. Okay. They'll cut 1 wire. They'll fit from one fuse to another fuse. From this fuse, again, they'll cut like this. Okay. So what happens when both of them get shorted, the current goes off. Okay. Here also the current goes off. So when these guys, when they come the next day, what do is they come and they pull both these wires. The moment they pull both the wires, all of them got connected in series and they start glowing. That's how it is. Again, when they want to switch off, there'll be a small spark there, but that won't affect anything. So they'll take that small piece of wire, they'll connect like this. Again, light comes. Again, they'll connect like this, light comes. If they don't want the light, they'll take it off. This is the use of shorting. They were in series, they shorted and make it parallel, because parallel always means off. Series always means on. So here it was off. So basically I connected them and reconnected them again here to make it on. That's the meaning of it. Fine. The moment you take off the wires, it will be parallel. Remember that. Next one. Shorting. That's called shorting. I'll give you one more. Enough. Okay, this is 10. This is A. This is B. Here, there's 10. There's 10. There's 10. So if you see from A to B, I'll start. One path is the ground path. The other path is this one. From A to B, if you see, all of them are in series. 10 plus 10 plus 10. 20, 30. So it looks like this. 30, and here, this is 30, this is 10, this is A, this is B. So again, if you see, both of them are parallel with each other. So you do 30 into 10 by 30 plus 10, which is 40. Okay. 7.5 will be the answer. 7.5 ohm. That's it. Okay. Done. Enough. Please practice the derivation today, whatever we did today. Okay. We'll do cells tomorrow's class. Again, we have a class tomorrow. I hope you guys remember that. We'll do that cells thing. Along with that cells thing, we'll also do Wheatstone network. Fine. One small part is there with respect to power, but not required. Tomorrow's class, cells will do series and parallel, and Wheatstone bridge. Both of them will come. Like I can't even tell Wheatstone is not important. Even that is important. Okay. Numerical based on Wheatstone bridge, not been asked in recent times, but derivation they'll ask. So tomorrow's class will finish off the theory part of it. Numerical, no, but theory will do. Okay. Practice today's derivation. It's mostly a college exam question compared to board exam question. It has also been asked in board exam, but mostly it is college exam, because board exam they have a lot of choices. They'll ask cells either in series or in parallel. If they miss, they ask Wheatstone, and only if they don't want to ask any of these three things, only then they'll ask that sigma equals ne square tau by m. Okay, so this is the fourth option. But when it comes to college, they tend to give this and only then ask, because series and parallel they know that everybody will study. With Stonebridge, few people will skip, but sigma very important. Okay, yeah, see you.